Flutter is growing in sync. Till the last year, there were only 5 lakh apps that were developed using Flutter. But fast forward to the beginning of 2024, there are more than 1 million apps which are already available on the Play Store. This explains how quickly Flutter is gaining the reputation. So, without having any doubt, you should start your journey of becoming a Flutter developer. And how you are going to do that? We have created a set of top interview questions of Flutter, which will help you in cracking the interview with the ease. But before we begin, make sure to subscribe to our Intellipaat YouTube channel and hit the bell icon to come across more updates like this. So, without any further ado, let's get started.
Today, we will dive into some of the most commonly asked Flutter interview questions to help you ace your next interview. So, you must be thinking, right? Why should you choose Flutter in 2024? Let me tell you why. In 2021, Flutter outpaced React Native, becoming the most used cross-platform framework. And as of 2023, over 2 million developers have embraced this framework, indicating a substantial increase in its developer community. That's huge. And you know what? More than 13,000 plus job opportunities are worldwide in 2024 for Flutter developers and different Flutter roles. This is the time you should start your journey to become a full-fledged Flutter developer in future. We have collected the top interview questions in this video, which will help you out. So without any delay, let's start with our first question, which is, what is Flutter, and write the advantages of using Flutter. Flutter is a Google's portable user interface toolkit that allows you to create attractive, natively built applications for mobile, web, and desktop from a single codebase. So what do I mean by single codebase? Single codebase means that even if you are building apps for different platforms, you only need to require a single codebase for every app, whether it is an iOS or Android. Flutter was developed by Google, and it is an open source framework for building user interfaces for various platforms. There are many platforms in which you can create visualing apps like mobile, web, and desktop. So, what are the advantages exactly? First, as I already mentioned, it has a single code base, which means with Flutter, you write your app's code once and use it to deploy the app on various platforms. That's crazy, right? Actually, this saves development time and resources significantly for the developers. Then, moving on, Flutter has fast development process. It has a feature called hot reload, which allows you to see the changes you made to your code reflected in the running app most instantly. In simple words, if you are making any changes in the app, you will directly get to see in just a matter of seconds, which means it has decreased the development process time, as you can experiment and see the results quickly on time. Then we have interactive and visual stunning UIs. Flutter comes with a rich of widgets, which are pre-built UI elements like buttons, text fields, and many more. These widgets are highly customizable, allowing you to create unique and interactive UIs for your apps. And in the last, we have native app performance. So what exactly is native app performance? Despite being cross-platform, Flutter apps feels as smooth and responsive as native apps, which means even if the code is single and it has been deployed to many other websites, so what exactly is native app performance? Despite being cross-platform, which means whether it is deployed on iOS or Android, the feeling for the app will be smooth and responsive as the other native apps built specifically for each of the platforms. So it is telling you that even if you have a single code base and you are deploying it in Android or iOS, it will not affect the movement and the process of your apps. So these are the advantages of using Flutter. And I think this is why Flutter stands a chance in the other frameworks also. Moving on to our next question, which is explain Flutter architecture. So there are 3 types of Flutter architectural layers. As you can see from the screen, I have put a picture of the Flutter architecture. In the picture, we have 3 layers: framework, engine, and embedder. Framework has layers like material, widgets, rendering, animation, painting, gestures, etc. While engine has C and C++, which are including service protocol, composition, and many more. And in the last, we have embedder, which is platform specific, that has native plugins, apps, packaging, thread setup, and render software setup. So these 3 layers work together to streamline the app development process. So let's break down these layers and their functionalities into simpler words. First, I will start with the Flutter embedded layer. It acts as a bridge between Flutter and the native platform, like Android, iOS, web, or desktop. It also offers a platform specific API for Flutter to access functionalities like device sensors, battery level, and more. And it also provides examples like platform view widgets in Flutter, which can embed native UI elements within the Flutter app. Moving on, we have Flutter engine layer. It is the core layer of the Flutter. It has been written in C++ for exceptional performance, and it handles very well the fundamental tasks like rendering graphics, managing memory, and scheduling threads. And you know what? Flutter engine layer also communicates with the embedded layer to access native functionalities when needed. So you can say embedded layer and engine layer are indirectly connected with each other, and whenever is the need, they both connect to each other. And in the last, we have Flutter framework layer. It is written in a Dart language, which I will be telling you after some time. Basically, a Dart is a high level programming language which is known for its ease of use, like we have Python and other languages. And why we use Dart? Because it provides a rich set of pre-built widgets that serve as the building blocks for the app UI. This layer also handles state management, routing, and application logic. It is built on the top of engine layer, which I already mentioned before, and it leverages the engine's capabilities for efficient app development. So these are the three layers in the Flutter architecture. I hope you understood. So moving on to our next question, which is what build modes are available in Flutter? First one is the debug mode. Before that, in Flutter, build models determine how your app is compiled and optimized. So every model has a specific stage in the development lifecycle. So for that, we will be starting with our first mode, which is debug mode. This mode is used for development and testing, and it has many features like hot reload, debugging tools, and larger app size. So what is hot reload in debugging? It tells you the code changes reflected in the running app almost instantly, ideal for rapid iteration. Then we have debugging tools, right, which enable setting breakpoints, inspecting variables, and stepping through code for easier troubleshooting. And it also has a larger app size, which includes debugging information that's not needed in the final app. Then we have profile mode. It is used for performance analysis, which means in this mode we can analyze how the app is performing. It is a balance between debug and release mode. Release mode I will be telling you further, but before that I will be telling what exactly and how profile mode is connected to both the modes. So what I was telling is it is a balance between debug and release mode. It uses ahead of time AOT, which is used for compilation for faster startup but retains some just in time. It has smaller size than the debug mode, but it is not optimized for final deployment as it identifies performance bottlenecks before finalizing the app and makes your work much easier by finding the problems early. And in the last we have release mode, and I hope from the word release you understood that in this app distribution and deployment is done. So what are the features of this mode? First one is AOT compilation. As I already told in the above mode, AOT means ahead of time. So it fully optimized machine code for the target platform, resulting in the smallest app size and the fastest performance. Because the larger will be the size of the app, the more energy it will take and the performance will be affected at the end. And then we have no debugging information. It removes all the unnecessary data to make the app smaller and more secure. Okay, and in this mode it is used to generate the final app bundle, Android or iOS, for distribution on different app stores. So these are the three modes which are available in Flutter. Moving on to our next question, which is, as I asked before, what is Dart programming language? We will be knowing what exactly is Dart. Dart is a versatile programming language for building web and mobile apps. It focuses on speed, ease of learning, and strong tools. Dart can be compiled to native code or JavaScript, ensuring high performance. So this is one of the questions which interviewer will ask you for sure, as these are one of the beginner level questions which are mostly asked, as interviewer wants to know if you have the basic knowledge of how the Flutter app works. So you can mark it as one of the most important questions in Flutter interview question. Moving on, we will see how to explain the difference between stateful and stateless widgets. So I have divided the table into stateful widgets and stateless widgets. And in the left side, I have mentioned the aspects from definition, lifecycle, use case, performance, and examples of stateful widgets and stateless widgets. So what exactly is stateful widgets? a widget that maintains state and can change over time. So it is a widget that maintains its state and it changes if the requirements are needed. And on the other hand, we have stateless widgets. It does not maintain its state and it remains constant throughout the deployment process. Moving on to the life cycle of these widgets. Stateful widgets has a life cycle with methods like init state, set state, and dispose, while stateless widgets has only build method, no lifecycle methods. And what are the use cases exactly? So stateful widgets is ideal for dynamic UIs where state changes frequently. Suppose if your app needs a different type of calendar, so as per the calendar changes, you can make the dynamic UI according to your need. While in the stateless widgets, it is ideal for static UIs that don't change frequently. So for making change, you should always go for stateful widgets, not the stateless widgets. In the end, so we will talk about the most important thing, which is the performance. So obviously, stateful widgets can be less efficient due to state management overhead. As changes keep coming, the performance will be affected in the end. But stateless widgets has been constant from the start. So it is typically more efficient due to its simplicity and lack of state. So what are the examples for stateful widgets and stateless widgets? Stateful widgets are forms, toggles, dynamic list, and any UI that changes based on user input. As I already mentioned, suppose if your app needs a different type of calendar, suppose you want month before the year or before the date, it all gets changed by the help of stateful widgets. But in stateless widgets, it is not possible, as it has static text, images, buttons, and simple layouts. So if you want more better UI, you should go for stateless widgets. Otherwise, for more better performance, you should go for stateful widgets. Moving on to our next question, which is explain the difference between hot reload and hot restart in Flutter. In one of the starting questions, I already told what is hot reload. So there comes another term which is hot restart. So let's see what exactly is the difference between hot reload and hot restart in Flutter. Here also I have mentioned the aspects as definition, changes applied, speed of the process, use cases, and how the preservation of state is considered. So first we will start with hot reload. It updates the app while keeping the app state. As I already told, even if you are making any changes, you will get to see the changes in time on your app frequently. While hot restart means it restarts the app and clears the app state. So it means hot restart doesn't work on real time. First, it needs to restart the app, then it clears the app state. So what are the changes applied for both the processes? In hot reload, it updates code, UI, and state changes on the fly. While for hot restart, it reloads the entire app and starts from the beginning because it has to clear the app state. For that, it needs to restart from the start. And then we have speed for both the processes. Obviously, hot reload will be faster because it applies changes only when it is necessary. And it doesn't have any recurring process, so it doesn't have to restart from the start. So obviously, hot reload will be much faster. And now, we already saw that hot restart, as we know, that hot restart restarts the app from the start. So obviously, it will be much slower as it restarts the entire app. Use cases. So hot reload is ideal for UI tweaks and small code changes. You can't make significant changes in hot reload, while hot restart is useful for significant code changes or initial app setup. And in the last, we have state preservation. It preserves the current state of the app, while in hot restart, it clears the app state providing a fresh start. Next, we have how do you manage state in Flutter application? Once again, it is one of the most important questions. So state management in Flutter refers to how exactly you handle and update the data which affects your app's UI. There are actually several approaches, each with its strengths and weaknesses, but I have collected top 5 of them, which are stateful widgets, provider package, block pattern, mobs, and riverpod. So first we will start with stateful widgets. As we already know stateful widgets in the previous question, so this is one of the built-in approach, and it has a state class that holds the data and rebuilds the UI whenever the data changes. It is suitable for simple apps, but it can be very complex if your state management is across multiple screens. Then we have provider package. Provider package is actually a very popular package. It uses a dependency injection pattern. As you define a state object, often a change no filter, and use a provider widget to make it accessible to descendant widget. It allows for better state sharing between screens. Then we have BLoC pattern. BLoC means business logic component. It is an unidirectional data flow architecture where events are dispatched to a BLoC object. The BLoC transforms these events into states, which are then provided to the UI. This pattern promotes separation of concerns and testability. Then we have MobX. MobX is reactive state management library that uses decorators to automatically track and update the UI whenever the data changes. It offers a concise syntax but might have a steeper learning curve. So basically MobX is a state management, but it has a very complex learning curve. So you have to be very clear when you are using this type of state management in Flutter. And in the end, we have Riverpod. It is a new state management solution and it is inspired by the provider pack. It has to be very simpler and more lightweight while offering the similar functionalities like the other widgets I already mentioned above. You know what? Flutter offers a rich ecosystem of third-party packages that extends its functionality as these were the different states to manage in Flutter application. So let's move on to our next question, which is what are some popular packages used in Flutter application? So there are some popular categories and examples of packages used in Flutter development, which I have already mentioned in these 4 type of packages. First one is network calls, second is navigation, third is UI enhancements, and fourth is Firebase integration. So network calls contains DO. DO is a powerful HTTP client for making network requests with various features like interceptors, progress bars, and error handling. Then we have navigation. Basically, Navigator is a Flutter's built-in navigation solution for moving between different screens within your app. And we also have one more option as Go Router, a popular routing package offering features like nested navigation, code first routing, and automatic parameter execution. And third, we have UI enhancements. In this, we have Cache Network Image, Flutter, BLoC, and Shimmer. What is Cache Network Image? It efficiently loads and caches network images, improving performance and reducing data usage. While Shimmer creates a placeholder effect with a shimmering animation which loading data, enhancing user experience. And Flutter BLoC provide widgets specifically designed to work with BLoC state management, pattern, and simplifying integration. And in the end, we have Firebase integration. It is an official package from Firebase for integrating various Firebase services like authentication, Firestore, storage, etc. into your Flutter app. So these were the some popular packages used in Flutter application. Now we are moving to our next question, which is explain the concepts of layout in Flutter. As you can see from the screen, here it is a picture of a random layout and exactly this is how the layout looks like. So what are the different layouts? There are general layout, custom layouts, nesting layouts, and responsive layout. So basically, what is layout? Layouts are the building blocks that arrange and position your app's UI elements. These layouts are themselves widgets and they act as a containers for other widgets also. Layouts define how child widgets are placed within the available space, ensuring a structured and visually appealing user interface. So first we'll go with the general layout. There are many types of layouts in this as row, column, stack, position, padding, align, flexible, and many more. So what is stack? It overlaps child widgets on top of each other, which is useful for layering elements for creating depth effects. Then we have padding, as it adds space around its child widget, creating margins from the edges. Then we have align. It is a child widget within the available space according to the various options as top, bottom, center, etc. And in the last we have flexible. It controls how its child widget expands or shrinks to fit the available space. Then we have custom layout. While Flutter provides these basic layouts widgets, you can also create custom layouts as well by extending the stateless widget or the stateful widget class and overriding the build method. This allows for more better complex layouts, specific requirements of the users. Then we have nesting layouts. Layouts can be nested with each other to achieve more intricate UI structure. It means you can put together two of the layouts to make a better layout. For example, a row might contain multiple column widgets within it. So it creates a grid-like layout that we call as nesting layout. And in the last, we have responsive layouts. Flutter allows you to build layouts that adapt to different screen sizes and orientation. You can use widgets like media query to detect device characteristics and adjust properties accordingly. So these were the 4 layouts and the concepts of the individual layouts I have already told. So by understanding and effectively using these layouts, you can create a well organized and visually appealing user interface for your Flutter application. Okay. Then, how do you implement animations in Flutter app? Flutter provides a powerful and flexible animation system, and it allows you to create smooth and engaging transition in your app's UI. So let's break down and see how to implement animations in a Flutter app. First one, we have animation class. It's the core of animation in Flutter, and it is called as the animation class. This class represents a value that changes over time according to a specific curve like linear, ease in out, etc. It doesn't directly affect widgets, but provides the animation data. Then we have animation controller. It looks like a controller and it controls the different animations. The animation controller manages the life cycle of an animation. It controls aspects like starting, stopping, reversing, and settling the during of animation. Then we have animated builder. This widget rebuilds its child widget whenever the value of animation changes. You can access the current animation value within the build method of animated builder and use it to modify the properties of the child widget. It allows you to create animation based on the animation value. Then we have pre-built animated widgets. It offers several pre-built widgets like animated opacity, animated container, animated padding, etc. These widgets simply animation by directly taking an animation object and animating a specific property based on the animation value. And in the end, we have custom animations. For more custom animations, you can combine animation controller with the animation builder, as I already told before. To create custom widgets like that, you have to use the animation value to control their appearance or behavior. Moving on to our next question, which is how do you optimize performance in Flutter app? So first we start with minimizing widget rebuilds. Unnecessary widget rebuilds can cause dropped frames and jank. Use const for widgets that don't change and avoid rebuilding entire widget trees when only a small part needs to update. Consider the key property to efficiently identify which widgets needs to be rebuilt. In this process, it happens. Then we have optimize build methods. In this, you have to keep your build methods lean and efficient. Break down the complex widgets into smaller and stateless ones. Avoid expensive operations like network calls or complex calculations within the build method. Then we have manage asynchronous operations. Use async, await, or future builder to handle asynchronous tasks without blocking the UI thread. These prevents like to app from freezing while waiting for data. Then we have optimize image loading and utilize profilers. This type of packages like cache network image to cache downloaded image and avoid redundant network requests. Consider pre-scaling images to the appropriate size for your device. And Flutter DevTools also provide performance profiling tools which is used to identify bottlenecks in your app. Bottleneck means the different errors which comes in between the execution. It is also used to analyze frame timings and widget rebuilds to pinpoint areas for optimization. And in the last, we have reduce package imports and optimize for release. So only the import are the specific functionalities you need to learn from packages. Large libraries can increase the app size and potentially impact the performance by making it slower or by taking more time for execution. And you can also use the release build mode while deploying your app. This generates a smaller but more optimized version with features like AOT compilation. Now we will see how to describe different ways to handle user gestures in Flutter. Flutter offers various ways to capture and handle user gestures, providing an interactive experience for your app. So here are the few breakdowns you can see from the screen. We have gesture detector, inkwell, recognizers and gesture arena, raw gesture detector and dismissible. So what is gesture detector? It is a versatile widget which is a foundation for handling various gestures like taps, drags, swipes and long presses. You can also define callbacks for specific gestures and then the widget will detect and trigger the appropriate callback whenever the user interacts with it. Afterwards we have inkwell. If you specifically want a tappable area with a visual feedback, you should definitely use inkwell. Builds upon gesture detector by adding the visual feedback while still allowing you to define callbacks for different gestures. Moving on, the third, recognizers and gesture arena. It all happens behind the scenes. Gesture detector uses a gesture recognizers. These are specialized classes that identify specific gestures based on user touches. Multiple recognizers can be active simultaneously and the gesture arena arbitrates which gesture wins on which factors like touch location or order. Then we have raw gesture detector. It is used for low-level gesture handling. This provides access to the raw touch events like pointer, down, move, up, and without interrupting them into higher-level gestures. It offers more control but requires you to handle interpretation of touch events yourself. And then in the last we have dismissible. This widget simplifies handling dismissible elements like swipeable list items. It listens for gestures like swipe and provide callbacks based on the dismissible direction, which are left, right, or etc. Now we will see the different approaches for error handling and crash reporting in Flutter. First we have in-app error handling. Then we will see crash reporting services. In app error handling, you should use try-catch blocks to catch potential exceptions within your code. Within the try block, place your code that might throw errors. And the catch block handles the exceptions. You can prevent the app from crashing. And you can also display user-friendly error messages or take corrective actions in this type of approach. And then we have crash reporting services. In this type of approach, you have to integrate services like Firebase Crashlytics or Sentry. These are the services that automatically captures crash reports when your app encounters unexpected errors. And the reports provide valuable information like the error type, stack trace, and device details. It also analyzes the reports to identify the common crash causes and fix issues before they impact a wider user base. So, by combining in-app error handling with crash reporting, you can proactively prevent crashes and identify issues efficiently and ensure a smooth user experience for your Flutter app. So here are a few tips to crack Flutter interview. First, you should master the basics. As I mentioned, few of the questions like stateful versus stateless widgets, hot reload versus hot restart, build context, and also the strong fundamentals. So you should master these type of questions. Then you should also practice state management. You should also understand provider, BLoC, or riverpod, and then you need to show your ability to handle complex app state. And you should also optimize for performance by knowing techniques like reducing rebuilds and using profilers. In the end, efficiency is key for the smooth apps, and it totally depends on you. And then you also have to embrace the widgets, as you need to explore different custom widgets and layouts, and by demonstrating your understanding of building UIs in Flutter and putting it into the real life action. And obviously you have to be staying updated as Flutter evolves rapidly. You need to follow trends and explore new features and adoption rate, and obviously the jobs available in the market in the current scenario. So these are the few tips to crack your Flutter interview, and all the best. If you found it helpful, then do share it with your fellow mates, and also don't forget to subscribe to our Intellipaat YouTube channel for regular updates like these.
Just a quick info guys, Intellipaat offers a full stack developer course which enable you to learn tech stack from both front end and back end. Through this course, you will gain hands-on experience with the skills and technologies such as SQL, Java, data structure, JavaScript, HTML, CSS, Node.js and React under the guidance of industrial professionals. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonial on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new heights. So visit the course page link given in the description and take the first step towards the career growth with the full stack developer course.